Hi, for this video what I want to do is talk to you about how can we analyze and graph a rational function by hand. And for this one what we have is we have a rational function f of x equals 2x squared plus 5x minus 3 over x squared plus x minus 6. So in order to graph this easily, we want to look at a couple of things. The first thing is we want to look at the domain because we want to see if there's any restrictions on our x values. We want to find the vertical asymptotes or the holes in the graph, find the horizontal or oblique asymptotes, find the intercepts, and then we will end up graphing after we find all of those pieces. And for graphing, what you can do is when we get to this step after we've looked at all of the other things, we can pick some points that are in our domain for x to be able to plug in to kind of see which way the graph is going to go. So before we start, what I want to do is see if I can factor the numerator and the denominator. Okay, for this one, remember that when you have a number in front and you're looking for factors, you do have to multiply the first times the last. So we're looking for two numbers that multiply together to give me -6 that add up to be the middle number of 5. So be careful with this one. Anytime you have -6 and 5, there is more than one possibility. Since the top one needs to be negative, that means I have to have a negative value and I have to have a positive value. And for this second one, I have to make sure that my positive value is larger. So this ends up giving me 6 and -1 are my two factors that I added together in the middle to get the 5. So what we're going to do now is we're going to look at this first number, 2. I can't divide 2 into 1, so they didn't have anything in common, so this part simplifies into 2x minus 1. Okay, the second factor, remember that we had to have something where we did 2 times some value gives me 2x squared. So for this one, because the second one has a 6, that means that I had to distribute this 2 into the second parenthesis. So I can see that 2 and 6 have a 2 in common, so this has to be x, and then I would divide this by 2, and we would get plus 3. So this ends up giving us the top part if we factor it. I'm going to go ahead and erase this part over here. Okay. Remember that your goal is that if I were to FOIL this back out, it would give me this back. So 2x times x is 2x squared. This gives me the 6x that I needed. This gives me the -1, and it adds up to be 5. Okay, for the denominator, we're just simply looking for two numbers that multiply together to give me -6 that add up to be +1, and that ends up being x plus 3 and x minus 2. Because 3 times -2 is -6, and 3 plus -2 gives me +1 in the middle. Okay, so the simplified form of this rational function is 2x minus 1 over x minus 2. Okay, so when we get down to the graphing part, this is essentially what we're graphing because this term right here cancels out. Okay, so let's start talking about all of the things that we have down here. Remember, the domain is all values where the denominator does not equal 0. So for part A, what we're going to do is we're going to take the denominator of the original one, the x squared plus x minus 6, and remember that this cannot equal 0. Okay, so when we're looking at this, we already factored this into our x plus 3 and our x minus 2. So we can say that x cannot equal -3 or x cannot equal +2. So our domain is all values of x such that x cannot equal -3 or 2. If you have to write it in interval notation, you would say that it's from -infinity up to -3, or it's from -3 to +2, not including it, or it's from 2 to infinity. So a lot of times set notation is easier on this one, but either one is acceptable. So we did the first one. Okay, the next thing that we want to do is we want to find our vertical asymptotes or our holes. And remember that the vertical asymptotes or holes come directly from the domain. So what we want to look at up here is we want to look to see if something cancels out, that means that we have a hole at that point. If it does not cancel out, that means that we have an asymptote at that point. So for part B, we would have a vertical asymptote at x equals 2 because the 2 did not cancel out. It's remaining here, so this one did not cancel out. Okay, and we would have a hole when x is -3. So it would be undefined at that point. We would just leave an open circle at x equals -3. So we'll see where we put that on our graph in just a minute. Okay, the next part we have to look to see if it has a horizontal or an oblique asymptote. So remember, the difference between these two is you're going to look at the original function and you're going to see what's true about the degrees. Okay, so if the degree of the numerator is less than the degree of the denominator, then you always have a horizontal asymptote at the line y equals 0. If the degree of the numerator equals the degree of the denominator, that tells us that we're going to have a horizontal asymptote. Okay, so for part C, we're going to have a horizontal asymptote at y equals the ratio of the leading coefficients. So if you look, our leading coefficients are 2, and this is understood to be 1. So we would put 2 over 1, which just means that it is at 2. So I'm going to go ahead and put my vertical and horizontal asymptotes on my graph. So remember that we have a vertical asymptote at x equals 2. So we would go to where x equals 2. We have a vertical asymptote here. Okay, we have a horizontal asymptote. Remember that our horizontal asymptote is at y equals 2. Okay, so this is our horizontal asymptote, and this is our vertical asymptote. Okay, and so then what we need to figure out is whether it's going here, 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 or like opposites of each other, or if it's going to be next to each other. So the next thing that it asks us to do to analyze is to find the intercepts. Okay, for part D, the intercepts occur when the numerator of the simplified is equal to 0. So if we go to our simplified rational expression 2x minus 1, we're just going to simply take the numerator, which ends up giving us 2x minus 1. So for my x-intercept, sorry, this should be x-intercepts. Okay, so for the x-intercept, we're going to say that 2x minus 1 equals 0. And then if I solve this, we would get 2x equals 1. So x equals 1/2. So that tells us that we have an x-intercept at 1/2 comma 0. Okay, so this is for the x-intercept only. The y-intercept occurs and again, for this one, we're going to use the simplified version. So we're going to take this part right here, the 2x minus 1, when the x is 0. So we would do f of 0 equals 2, and since it was 2x minus 1, we would do 2 times 0 minus 1 over 0 minus 2. So if we simplify this, we would get 1/2. So that tells us that we have a y-intercept at 0, 1/2. So if I put this on my graph, we have at y equals the y-intercept at 1/2, and we have an x-intercept at 1/2. Okay, so what we can do for graphing this is to fill in the last part. The easiest thing to do is just to kind of pick some points to plug into here. So if we plug some points into here, we can see what that gives us. So for this one, let's say that we plug in -1. We want to see what happens if we plug in -1, and we have to remember at -3 we're going to have a hole. So wherever this graph goes at -3, we do have to remember to put our hole in. It's very hard for me to do these problems on a small screen just because it takes up so much space. So with this, what we're going to do is you can just pick values for x that are in your domain and then just plug it into this equation. Okay, so to get our ordered pair, so let's say that we picked -1 for x because that's in our domain. So we would simply plug in -1 into here, and so we would end up with -2 minus 1, which gives me -3, over, and on the bottom, if I plug this in, it gives me -3 over -3, which ends up being +1. So we can see at this point right here, we have a point, and then it's going to continue to get closer this way. We have a hole at 1, 2, -3, so we have to make sure that we put an open circle there, and then everything else would fill in here. And then we've got to find some points to the other side. So we want to make sure that we go to both sides of the vertical asymptote and pick some points. We don't have any other restricted values that we would have holes at that point, so we would come over here to x. And let's say that we picked 3 and 4. Okay, and if I plug 3 into here, this would give me 2 times 3 is 6, minus 1 would give me 5. And 3 minus 2 would be 1, so this ends up giving me the ordered pair 3, comma 5. So at 3, I would be at 1, 2, 3, 4, 5. And then if I plug in 4, 2 times 4 gives me 8, 8 minus 1 gives me 7, and 7 minus 2 gives me 2, so at 4 I would be at 3.5. So if I count up 1, 2, 3.5, it shows me that it would be right here, so this graph would continue to go this way and curve out. Okay, a lot of times with rational functions, it's easiest to plug this into a graphing calculator because of all of the information that you do have to find in order to graph it by hand, and you can easily see what the graph does. You do want to make sure that you look for holes or know how to find the holes if there are any, because your graph will not show it. It'll show it as a point that it goes through. If you look at the table, it will tell you that there's a hole because it's undefined. As always, thanks for watching. If you have any questions, please let me know. If there are additional topics you need me to cover, please let me know as well.